Welcome to the biodiversity module. And we all know that we are in a biodiversity crisis right now in the world, but also particularly across Europe, both for the habitats, but also for species, protected species. And this is driven by two things. First is, of course, habitat loss, but also the health of the habitat themselves. And from the last evaluation from the EA, you can see that most of the habitats are in poor condition or bad condition, and the outlook assessment for species status is also bad or poor. So it's a kind of a bleak assessment, but that's why we are here. It's to offer some kind of solutions and hope, because in quarries you can actually have a positive impact. There are a lot of opportunities that can open just by the fact that you open new habitats in the quarries. As you can see on the illustration, you have the extraction phase, you have the cliffs, you have the restored parts, and all do host particular conditions for specific habitats, which can be rare, protected, or used to connect different parts of the landscape. So using this opportunity is actually important to go beyond just biodiversity monitoring. And also, as you know, the legislation has changed a bit with the nature restoration law, and countries have to adapt and come up with plans and quarries with those opportunities in mind, with particular protected habitats and species, can actually play a role in meeting those objectives. It is also important because in the Rotate project, what we did was going beyond what was going for now. We addressed the multidimensional aspect of nature through ecosystem services. So it's not only the diversity of species and habitat, but it's also what habitat provides to us as provisioning services, let's say food, timber, fuel, wood, fire, anything, but also regulating our environment with the climate, regulating our water cycle, regulating the disease spread, and so on and so forth. So all of this can be supported by ecosystem, and it's actually interesting to put that in perspective in the sector. And also for now, in most of the quarries and most of the countries, restoration has been limited to rehabilitation of the ground and then early stage rehabilitation of the ecosystem. But restoration of ecosystem goes much further than just rehabilitating the place. It goes to the function of the ecosystem, it goes to the health of the ecosystem. And so we emphasized during the work that restoration can go beyond and can actually address those aspects of health of the ecosystem also, and not only costing a lot of money, but also can be partly spontaneous or assisted. We also identified trade-offs because different ecosystems and habitats do have different characteristics using that multidimensional approach. And as you can see on the graph, you have on the y-axis the carbon index, which is, for example, the combination between the absorption of carbon and the storage of carbon, and in y-axis the biodiversity capacity of the habitat. And you have the points are basically the type of habitats in Europe from the UNIS database, which is a standardized version of designating the habitats. And you can see some habitats do have a very high biodiversity support, but very low carbon storage, and vice versa, or both. Some have both. So identifying those trade-offs is important when you address the restoration and the goal of restoration, because you can go in different directions. But it also, within the carbon itself, for example, which was the topic for the Rotate project, that some habitats do have a very high carbon storage capacity, but takes up carbon very slow. Or conversely, they do have a very low carbon capacity, but they can take carbon from the atmosphere very fast. So again, depending on the objectives, you can basically orient the strategy towards one habitat on the other. And that's why the module is trying to achieve, is supporting with data and suggestion the decision-making process. So we summarize everything with KPIs. We also identify knowledge gaps, which is very important. And we provide year-to-year tracking, and the suggestion for decision-making is kind of important also. There is 5 sub-modules within the module itself. The pre-assessment, which we found is crucial. It's a kind of data check. It helps identifying the operator, which document they do have, which document they don't have, which can support then a biodiversity strategy. And if they don't have it, then maybe they should either update or carry a study to get the data. We have the biodiversity KPIs, we have the ecosystem services, the regulating ones. We have the carbon calculator that helps know how much carbon it takes up or stored. And the provisioning ecosystem services, which is basically the food, timber, and everything out of the mineral extraction. The biodiversity KPIs were developed from our previous work and divided into two tiers. The first tier, which is a pre-assessment, that is, as I said, the data check, if you will. And the second tier, which is the functional level of biodiversity, species, and habitat. It's been in a participatory approach then to the UPG members, and we got 121 answers in 15 countries. And they actually helped shorten the questionnaire, make it more workable with, and also with the 5 pilot site, of course, and have a version that is now in the platform itself. Biodiversity KPIs, there are 10 of them, a number of species, number of protected species, and then if they have countings of each of them of the species, and the same goes for the habitats. For the ecosystem services, we identified 19 types of habitat which are found across Europe. They are, as you can see, kind of broad definition, broadly forest, coniferous forest, screes, seasonally wet forest, but also human-made or human-transformed habitats, like the extraction site is a habitat. And within each of these 19 habitats type, we graded 15 ecosystem services which address the hydrological cycle, the purification of the environment, the support of biodiversity in green, and the climate regulation as last. These are expert-based on a semi-quantitative version from 0 to 5. So 0 is no service and 5 is excellent service. In the platform, basically all of this is kind of hidden from the user. All you have to do is knowing which habitat you have and how much you have. This is the simplest way to do that. And it's already a challenge for some of you, I know. But basically you just say I have 3 hectares of forest, of deciduous forest, and I have 1 hectare of lake, for example. And then from this, the module will actually calculate everything. It will still provide a table with everything, so that it's entirely transparent, with the share of each habitat you have in the site and the ratings of each ecosystem services for this habitat. And visually, it will give you 2 things. The first one, the multidimensional aspect of the nature in red, with a radar graph addressing each component of the regulating services, and the score attributed for the entire site of the quarry, not only the habitat itself, but everything aggregated, from 0 to 5. And then provide you also with biodiversity and carbon support score, since it was a big topic for the Rotate project that we have, biodiversity, but also carbon. We compute them from the carbon index and the biodiversity support, aggregating the score, which are for carbon and climate, and aggregating the score for biodiversity support. And that helps also identifying which strategy is leaning the configuration of the query you have, if it's more supportive of biodiversity or of carbon, and if you want to go in one of the other direction, then it comes up with suggestion to which habitat to extend, restore, or add to the configuration for supporting biodiversity, and also why. Or also for the same goes for carbon. Of course, this is a suggestion. They have to be evaluated against what you have in the query. So if there is protected species, of course, protected species will always come first, and you maintain those habitats, and then you extend or replace them with something else. For the carbon calculator, it's exactly the same. You have basically to know how much habitat you have, know the area of them, and you are presented with the table where you have basically the data you entered and how much carbon it takes and how much carbon it stores per hectare, and the summary for the site in a visual way. So the first one is a disclaimer that the carbon content and the carbon uptakes are for healthy habitats at maturity. which is a big hypothesis, and so far science hasn't been able to track the carbon uptake and storage for every stage of a succession. So we did what we can do. A healthy habitat at maturity may not be what you have in a quarry, but at least it defines a baseline. So you can compare year to year rather than actually using those values per se, because they are subject to high uncertainty. That's also why you have potential minimum and potential maximum carbon, because depending on where you are, the climate, the condition, the microclimate, the micro condition, the soil type, then you have a lot of variability in the carbon content. But it is a baseline, and it helps tracking how much carbon is stored in the quarry. Oops, sorry. You have the graph, the first graph on the left, which is about how much carbon is stored per habitat, and then you have the graph on the right, which is the relative share of the carbon stored within the habitat for the whole site. So you have two types of graphs that helps identifying where the carbon is stored and how much carbon is stored by each habitat in the quarry. For the absorption of carbon, so this one is about how much carbon do the ecosystem takes from the atmosphere year per year, for example, for vegetation to grow and grow roots and so on and so forth. We did exactly the same exercise and exactly the same hypothesis. That is for habitats at maturity. We did 4 time horizon, 1 year. So after 1 year, that how much carbon that the ecosystem take at the site scale, 5 years, 20 years, 50 years. So if you know that you have been rehabilitated a part of the site for long-term rehabilitation, then you know that after 50 years you can expect that much carbon to be absorbed, not stored, absorbed. That's a bit different. Again, same graphs. You have the potential absorption and maximum and minimum because of the variability, and then you have the absorption per ecosystem, and then the share for the whole site. And we summarized every temporal horizon on another graph so that you can compare how much is after 1 year, 5 years, 20 years, 50 years, and you don't have to calculate it and press on a button, so you have access to all the information. Again, this is, as I said, the hypothesis is strong, but it serves as a nice baseline to know where you're going with a kind of configuration you have, and if you have a plan to restore something, where you could go. So impact and benefits, we have actually in terms of impact, the objective were to be simple to use, and discussing with the site and discussing with UPG, it has to have minimal inputs, because biodiversity is something which is complicated already, and in the grand scheme of the quarry operation is not always aligned with the rhythm of the quarry, not always in terms of data. So minimal inputs, it has to be easy to understand because not everybody is a biodiversity expert, and it has to be scale independent, so because it has to be applied in Norway, it has to be applied in Spain, in France, in Germany, whatever, regardless of the country it is. So this is the first impact and benefit that we have, is that it is kind of simply to use, it is relatively easy to understand, and is scale independent. It's also impact the data and support decision making. As I said earlier, this was one of the big objectives, is that it has to be easily understand, but also rich in information. So KPIs identify knowledge gaps, which is, I think, the most important part of it, to help the sector grow into a better place for nature. And what is, I think, the most important in what we did is that we went beyond simple biodiversity management. We went into anticipation and dynamic, showing that the quarry can host, that the quarry can host a lot of biodiversity in different places. But also we went beyond biodiversity, addressing nature multidimensional aspect with ecosystem services. And this multidimensional aspect is very important to address nature restoration law also, because it has a component on ecosystem health, on pollination, and so on and so forth. So you could use that module also to go beyond just biodiversity. We also produced 2 deliverables. The first one is the handbook chapter on the state of the art of nature management in quarries. It's theoretical, conceptual, but it set the scene nicely. And we got guidelines, and that is how to apply this theory into quarry and nature management with methods, measurements, planning and restore in different parts of the quarry. So what to do in the extraction phase, what to do in the transition phase, and what to do in the restoration part. And with that, I thank you.